Good morning. Hope everybody's having a great start to your Tuesday, December 11. I'm meteorologist Reed Timmer with TVN and this is your daily Weathercast. We're planning on launching these every day from here on out. We'll start off by releasing these trial versions on Facebook and our other social networks, and the plan is to transition it over to TVN once we get it dialed in. As you can see, I'm definitely not a blue screen kind of guy. I'm a lot more comfortable out in the field. But still, love the weather, and we've got a lot of great information to talk about. I'm really excited about this, and there's also a chance for severe weather today in southeast Florida. We'll talk about that setup, and people should definitely be staying tuned to the warnings down in Florida today, because there is an isolated tornado potential, as there was yesterday. And yesterday, there were actually several tornadoes in the southeast U.S. There were 10 tornadoes, first early on in the day in southern Mississippi. And then later on, there was one tornado in Florida, and I'm actually surprised there was only one report, especially given the size of this tornado. This photo right here doesn't do the size of the tornado justice. It was actually a wedge at one point with a 1/4 to 1/2 mile wide width. But the reason that I chose this still image is because it shows a textbook suction vortex within this tornado right as it crossed the road in front of this guy. And he's just driving down the road, and this tornado is right in front of him. Honestly, I'm extremely jealous, because this would have been a perfect intercept opportunity for the Dominator. But it's those suction vortices that motivated our build of these armored vehicles, so we can get right up close to them and measure just how strong the wind speeds get. Some theories show that in the strongest tornadoes, those suction vortices could pack winds of 400 or 500 miles per hour. But in this case, the tornado probably wasn't nearly that strong, but you can see the parent vortex, or that cone above it, and then that suction vortex. And what causes the parent vortex to break up into these miniature tornadoes is the interaction of the vortex with the friction of the earth. And in this case, right after the photo, this tornado expanded to about a 1/2 mile wide in width, and our good veteran storm chaser friend Darren Brunin happened to be down visiting a friend in Florida, and he chased this storm and captured an incredible photo that shows the tornado at its maximum width, and it definitely looks massive. It's hard to tell how strong it was until we hear about the damage survey today. Definitely stay tuned. As soon as we hear that information, we'll post it. And as I said, there were several tornadoes, actually 10 tornadoes yesterday. Started off in southern Mississippi, southeast Louisiana, very close to the New Orleans area. There were a few severe wind reports in Alabama, but then there was the one tornado report in Florida. And again, I wouldn't be surprised if more reports pop up as damage surveys are done. But that tornado in Florida yesterday is what we call a mesoscale accident. And while the conditions looked favorable for severe weather and even supercells in Florida, the low-level shear was lacking overall over large areas. So we didn't expect a large outbreak by any means. But one thing about Florida during this time of year, or actually any time of year, is it's a peninsula that extends out into the ocean. And right near those coastlines, you can get an interaction with the ocean that can change that surface wind, and that can enhance the wind shear to incredible amounts, actually, just over short periods of time, over small geographical areas. And in that case, there happened to be an isolated storm that interacted where those ingredients came together, and it produced a relatively strong tornado. And to me, it looked like it had violent motion in the video. But thankfully, there was no loss of life or property, and the people there definitely dodged a bullet northeast of Orlando. And here's the setup for yesterday, and then I'll lead into the setup today. And we do expect severe weather in Florida, as I mentioned again today, but I'll tell you how the setups are different and what threats we expect today over South Florida. But yesterday, this was a textbook example of where the two different jet streams that usually traverse North America during winter, especially the winter season, you have the polar front jet stream to the north and the subtropical jet stream to the south, and where they interact right at the base of that trough in the polar jet stream. What that causes is it enhances the vorticity, or that rotation right at the base of the trough, and that can build the amplitude and make that a much stronger storm system than it would have been if you didn't have a subtropical jet stream there. And typically during El Nino years, when you have that warm water in the tropical Pacific, that leads to an intensified subtropical jet stream. And during El Nino years, if the North Pacific climate system lines up, you can get these troughs of low pressure that get much more intense and enhanced by the subtropical jet stream. And the polar front jet stream is caused by a completely different phenomena than the subtropical jet stream. The polar front jet is driven by the temperature gradients that reside over North America during winter. You've got a lot of warm, humid air to the south, very cold air up in Canada at temperatures 20, 30 below. And it's that temperature difference that causes that strong channel of wind at high altitudes. And that's up around where planes fly. And we call that basically the jet stream or river of wind up there that drives and modulates our weather over the U.S. But the subtropical jet stream you can see there to the south that exists at a little bit of a higher level in the atmosphere, and that's driven more by the oceanic heat in the tropical and subtropical Pacific. And during El Nino years, when you get those positive sea surface temperature anomalies, that could lead to those stronger subtropical jet streams. And you can see in the upper left, that's the latest sea surface temperature anomaly pattern in the Pacific that I could find. And that doesn't show particularly strong anomalies. This is a very weak El Nino, and it's always been in question whether a full-fledged strong or moderate El Nino would even materialize. But this El Nino seems to be kind of petering out, and it'll resurface and just hasn't really gotten entrenched just yet. But if you look at the pressure difference between the Southwest Pacific and further east, which is another measure of El Nino, which sometimes that pressure difference, when it's smaller, that can precede the development of stronger and warmer sea surface temperature anomalies in the tropical Pacific in that red circled zone. But regardless, the pressure difference across the Southwest Pacific and further east is anomalously low. And that has led to the development of these 0.5 to 1.0 degrees Celsius anomalies in the tropical Pacific. And that's what's driving that subtropical jet stream that in part was responsible to the tornadoes yesterday in southern Mississippi, southeast Louisiana, and also in Florida. And now here's today's pattern. This is also the jet stream, and it shows that it's different. I'll go back to the previous slide. You could see yesterday's polar front jet stream trough was neutrally tilted. That basically means the axis of the trough is closer to north-south. And then as you transition to today, this is the forecast for this afternoon, you can see that polar front trough has become more positively tilted. So the axis of the trough, the main axis, where you see that curvature, goes from southwest to northeast. And usually when you get this positive tilt, it reduces the chances of tornadoes in the warm sector because you get lesser wind shear, changing wind speed and direction with height. You get more wind speeds that are unidirectional or the same direction from the surface all the way up to the jet stream. But in this case, you have speed shear. So you have weaker winds at the surface, and you've got these strong 50 to 60 knot winds at 500 millibars, which is at jet stream level. And that speed shear can still create supercells. But I expect today would be more of a squall line that should develop north of Orlando around noon and then slowly sag south across the state. But if you do get one of those mesoscale accidents and you can get one of those surface wind barbs to change just slightly, there easily could be tornadoes in Florida today. And the Storm Prediction Center did put out a slight risk. Here it is right now. It stretches basically from Lake Okeechobee north to the north of the Orlando area. And based on the models, it looks like the wind shear is actually stronger in the northern part of that slight risk area. And I expect storms to develop earlier up there, probably around noon or 1 o'clock, and that's when the tornado threat is going to be maximized. But as the afternoon progresses, that wind shear should eject into the Atlantic, and it'll likely become kind of a broken squall line and maybe some marginally severe winds and heavy rain, lightning. But the tornado threat will definitely be early on in the afternoon in the northern part of that slight risk area. And stay tuned to Watches and Warnings, and we'll be posting about it all day on our social networks as well. And here's the model forecasts that support that. On the left is forecast precipitation at 1 p.m., and it shows those storms developing in northern Florida. And the plot at the right is what we call a hodograph. And it took me years to fully understand these, and still today sometimes they boggle my mind because you can get a hodograph that doesn't look favorable for tornadoes but still have tornadoes. And it's those mesoscale accidents that cause that to happen. So This is a forecast hodograph just ahead of those storms in northern Florida. And a hodograph is basically looking down at the atmosphere, and it's a measure of how the wind shear, changing wind speed and direction, changes with height. And when you have the strongest wind shear values, the hodograph has a very large curvature from the very bottom left portion of the plot all the way to the upper right. You get this very curved kind of hook-shaped hodograph. Those are the most favorable for tornadoes, but you also need a storm motion that is also favorable. And one of these days, I'll do an educational one of these and explain hodographs in detail. But this hodograph right here is not particularly conducive for tornadoes. It's kind of a straight line hodograph, but then has a lot of curvature a little higher up in the atmosphere, you can see there. But this looks a little bit more conducive for a broken squall line. But the surface winds are on the bottom left portion of that plot, and the winds at jet stream level are in the upper right portion of that plot. And if you can imagine changing the wind speed at the surface just a little bit, let's say you have a due easterly wind or due westerly wind of 30 knots, which could happen near the coast of Florida, where you interact with the ocean and get those changing wind speeds at the surface, changing wind direction. Can also happen with storm interactions. And so if you just change that wind direction slightly, you can change that hodograph into something that's very favorable for a tornado over a very small area, over a short time window. And if that happens, we could have a repeat of yesterday with another large tornado somewhere in Florida, most likely up in the Orlando area, the north part of that slight risk area. And looking at the temperature map, you can see that temperature gradient I was telling you about that drives the polar front jet stream. And in the southeast part, look at all the warm temperatures. You have temperatures in the 70s over the Florida Peninsula, and that's in the morning. You have very high moisture values down there as well, which is quite common with these El Nino systems. And there's not much in the way of cold air in the central U.S. Most of the cold air is trapped up into Canada, and you don't have those strong northerlies behind this system that's transporting that cold air southward. However, a little bit of the cold air did cross the Great Lakes, and there was some lake effect downwind of Lake Michigan and Lake Superior that I'll show you later. I'm obsessed with lake effect snow. It's very interesting, and I'll show you some radar plots of that in a second. But you see all the cold air trapped up there in the Canadian prairies. And we were just in Saskatchewan with storm chaser Sean Schofer rigging his snowmobiles for live streaming. So the next blizzard that happens up there in the Canadian prairies, we're going to surge north and try to cover blizzards from perspectives that have never been done for live, and we're going to stream those live to TVNweather.com. But if that cold air ever surges south, that's when winter is going to begin officially in the central U.S., but we'll just have to see if that happens. Some of the climate models that I've been running based on my graduate research shows that it's going to be an above normal winter in the central U.S. and especially the southeast, and so far that is verified, and most of the cold air has been trapped up in the northern Saskatchewan area, northern Alberta, and further north. But you can still see the warmth down the southeast. And another thing that this shows, and you see these wind barbs that are on the map. And those wind barbs near the Gulf of Mexico, just the northern part of the Gulf of Mexico, those show northerlies. But those northerly winds are only about 10 or 20 knots, and they're not that intense. It's not like this cold air is surging south and just clearing out all the Gulf of Mexico moisture. The moisture is just sitting there waiting. And so the next trough that comes in, if you have another strong subtropical jet, we could get another tornado event across the extreme southern U.S. And they are quite common during El Nino years. And actually the extended range models are showing a big storm system coming in and possibly even storm chase opportunities 7 to 10 days out. And here's this lake effect I was telling you about. And this is just a small part of that cold air was moving across Lake Michigan in this case. I actually grew up in Grand Rapids, right in the east side of there. And you can see on the left, that's that lake effect snowband that develops over Lake Michigan. And that happens as you have cold air go over the very warm lake waters. And you can get really intense snowfall rates. I've seen 70 inches in 1 week in Grand Rapids before off Lake Michigan. And you get even stronger lake effect downwind of Lake Erie and Lake Ontario. It's very common to get 40 to 60 inches of snow, especially in the Tug Hill Plateau region. Watertown, just to the east of Lake Ontario, and the wind is parallel to the lake. But these bands will set up parallel to the wind direction. In this case, those cold winds were north-northwesterly. But what prevented this from becoming a prolific snow producer is that there was wind shear. And different than supercells, where wind shear intensifies them, and lake effect snow, that changing wind speed and direction with height tears apart the bands and creates more of a cellular nature in these bands. So you get quick bursts of snow that could be 2 to 3 inches an hour, but they don't last very long. So we only had about 2 to 3, 4 inches of snow in extreme southwest lower Michigan, Berrien County, Van Buren County, and the left image is in the middle of the night. That was an image that I took earlier on. And watching the loops of lake effect is almost like meditation to me for some reason. It's amazing how you can see the radar echoes form over the middle of the lake and just continue to form and then move inland and then die out. And so you get these strong snowfall rates only over very isolated areas. And there's been several times where we've had no snow on the ground in Grand Rapids further northeast, and I've driven southwest, and there's 2 feet of snow on the ground and whiteout conditions in these bands. And that's actually how I started chasing. Back when I was 16, I would sneak out in my 1985 Plymouth Reliant and try to drive right into the heart of those snow bands, and almost had to make a snow cave a few times. But the image on the right is from this morning, and that shows how the lake effect is changing. The wind speeds are starting to shift. Wind directions actually are starting to shift more out of the southwest, and they're warming up, and that's causing those lake effect showers to move more inland. And so my mom was driving to school. She's a teacher there this morning, and she drove through that snow shower just south of Grand Rapids and had brief whiteout conditions for like 5 minutes. But trust me, they're definitely used to the lake effect up there, and lake effect is something I miss. And even down here in Oklahoma, there's been cases of lake effect snow. There's small lakes here, like Lake Oberholzer, for example, just to the northwest of here. It's a very small lake. And there's a smokestack just on one side of it. And it was very cold one time, and that smokestack was seeding the clouds. And you had a wind that was parallel to this very skinny lake. And there was an area with 4 houses in a neighborhood that received 4, 5, 6 inches of fluffy snow, just probably 4 or 5 houses. And outside of that, they had nothing. And so you can even get lake effect on even small lakes, like the lakes here in Oklahoma are basically dammed up rivers. But the Great Salt Lake gets quite a bit of lake effect. There's an area in southern Japan, just downstream of the Sea of Japan, that gets hammered with lake effect snow. It makes the lake effect in the Great Lakes here look like a joke out in Japan. And that's one thing that we'd like to chase someday, and see some of those prolific snowfall rates, so the thunder and lightning that you often get with lake effect because of those warm lake temperatures and the very cold air just above it. And tornadoes weren't only prevalent in Florida and the southern U.S. yesterday, but they also happened in the southern hemisphere. This is a tornado that happened in South Africa, and in the southern hemisphere, our fall and winter is their spring and summer, and it's the heart of tornado season out there. And actually, South Africa is very similar to Denver in the high plains. You have mountainous terrain, and the storms will move off those mountains and move over the deeper moisture in the plains, and you can get a lot of tornadoes, and actually a lot of strong tornadoes in South Africa. And our late friend Andy Gabrielson has always wanted to chase down there. So one of these years we'll take a chase to South Africa and dedicate that chase to our late friend Andy. It was one of the best chases I've ever known. And tornadoes don't only happen in South Africa this time of year, but they're also very common in South America. We storm chased in the Pampas of Argentina a few years ago, and Uruguay, just the northeast of Buenos Aires, actually had a very strong tornado just a few days ago. And I'd recommend looking this tornado up on YouTube and watching the video, because this tornado was the real deal. This was a violent tornado, in my opinion. And the tornadoes in the southern hemisphere rotate in the opposite direction. They rotate clockwise there, whereas they rotate counterclockwise here around that low pressure. And also, the tornado or mesocyclone is located on the north side of the storm instead of the south side of the storm. And overall this season, it has been a very active year in South Africa, particularly Uruguay. Here's another wedge tornado that happened in October. Insane video of this thing. I mean, look at these tornadoes. I mean, these are monsters. And a lot of times they go unseen because there's no storm chasers down there. And I'm hoping one of these years we'll be able to save up the funds again to go down to South America and chase these storms and try to capture a tornado like this and maybe ship the Dominator down there and even intercept it.